Okay, let's go. Number 10. The Murchison Meteorite. On September 28, 1969, just after 10:30 in the morning, a fireball tore across the sky over Murchison, Australia, and broke apart with a boom people felt in their chests from miles away. Chunks of rock rained down over nearly 7 square miles of farmland, and within days, scientists had collected more than 200 pounds of fragments, some still warm. Nobody in Murchison knew it yet, but they'd just watched one of the most studied objects in the history of science fall into their backyard. What nobody knew, not for years, was what was actually sitting inside that rock. The Murchison meteorite turned out to be a carbonaceous chondrite, an ancient, carbon-rich rock that formed billions of years ago, long before Earth existed. It never got hot enough since to cook away whatever chemistry it was carrying. Labs went to work on the fragments, and what came back should not have been possible if the meteorite was just space gravel. Researchers found amino acids, the building blocks of proteins, but the isotope ratios were wrong for Earth. Wrong in a specific way. On Earth, biological amino acids favor one mirror image form over another, almost every time, the way every clock in your house runs the same direction. In the Murchison samples, the two mirror image forms showed up in nearly equal amounts. That's exactly what you'd expect from chemistry with no biology behind it. And it's exactly what you would not expect if the meteorite had simply been contaminated by life here on Earth. Then it got stranger. Researchers working with samples at NASA's Goddard Space Flight Center identified actual nucleobases inside the rock. Xanthine, adenine, hypoxanthine, guanine, the same molecular letters that spell out DNA and RNA on this planet, sitting at concentrations between 114 and 655 parts per billion. Later analysis using more sensitive mass spectrometry techniques turned up even more of them, thymine and cytosine among the finds. And when researchers ran the carbon isotopes on that uracil and xanthine specifically, the numbers confirmed it. This material did not form here. It formed somewhere else, in the cold dark between stars, or inside the parent body this meteorite broke off from. And it had been riding around space carrying the raw vocabulary of life, long before Earth ever had a rock to catch it. I mean, think about that for a second. A meteorite that fell in 1969 wasn't just space debris, it was a chemistry set built somewhere that isn't here, and it landed on a sheep farm in Victoria, Australia, of all places. Now on its own, that's not a smoking gun. Amino acids and nucleobases aren't alive. They're ingredients, not a meal. A chemist could look at all of this and tell you, correctly, that abiotic, non-biological processes can build these same molecules, given enough time, enough radiation, enough cold. That's the responsible read, and it's the one most planetary scientists actually hold. But it does mean the universe apparently manufactures the parts for life as a matter of course, scattering them across asteroids and comets the way a hardware store stocks shelves, whether or not anyone ever shows up to build something with them. And that's exactly the problem, because Murchison wasn't a one-time fluke that some lab got lucky with. More than 50 years after it fell, researchers are still finding new compounds in the same fragments using instruments that didn't exist in 1969. It turns out this keeps happening, and twice, in the 21st century, 2 space agencies went out and got a second and third opinion on purpose, with every contamination question closed before the samples ever touched Earth's air. Number 9. Ryugu and Bennu. In a clean lab at Hokkaido University, a research team led by Yasuhiro Oba cracked open a sealed capsule that had never once touched Earth's atmosphere. Inside were a few grams of dark, crumbly grains, asteroid Ryugu, delivered by Japan's Hayabusa 2 spacecraft. It launched in 2014, reached the asteroid in 2018, and brought its samples home in a sealed capsule that stayed sealed the entire way, from collection in space to the moment it landed in the Australian outback. That detail matters more than almost anything else in this story, because it means whatever showed up inside couldn't have hitched a ride from Earth. Researchers soaked the tiny grains in hot water, then ran the liquid through high-resolution mass spectrometry to see exactly what had dissolved out. What showed up was uracil, one of the actual letters in RNA's code, the molecule that lets a cell read and copy genetic information. Sitting next to it was niacin, vitamin B3, a compound every living cell on this planet needs to run its own metabolism. Published in Nature Communications in March of 2023, and for the first time nobody could argue it was contamination, because the sealed sample chain never gave contamination a chance to happen. But here's the detail that everyone missed at the time. Ryugu wasn't the only asteroid that came back with a receipt like this. 6 months later, NASA's OSIRIS-REx mission dropped its own sealed capsule into the Utah desert, carrying samples from a completely different asteroid, Bennu, after a round trip that started with launch in 2016. When scientists opened it up, they found 33 different amino acids, 14 of which are the exact ones that build every protein in your body right now. They found all 5 of the nucleobases that make up DNA and RNA, all 5, sitting inside a rock that had been drifting through space for who knows how long. Alongside that, unusually high amounts of ammonia and formaldehyde sitting right next to it, 2 compounds that react together to form even more complex amino acids on their own. Plus salts rich in phosphate, sodium carbonates and sulfates and chlorides, the same kind of chemistry you'd expect from a briny ocean slowly evaporating somewhere it shouldn't have existed at all. 2 different asteroids, 2 different spacecraft, built by 2 different countries, on 2 completely independent missions that had nothing to do with each other, and the same result both times: the raw ingredients for biology, already assembled, riding around the solar system on rocks. The contamination excuse is off the table for good, in sealed capsules opened under conditions clean enough to satisfy the most skeptical chemist in the room. That's not one lucky meteorite anymore. That's a pattern, and once something shows up as a pattern instead of an accident, the next question stops being, did we get lucky, and starts being, how far did this ever go? Because one meteorite, found decades before either of these missions launched, already had a NASA press conference built entirely around exactly that question. And here's the part that still gets people. Ryugu handed back a little over 5 grams of material. Bennu handed back close to 120 grams, the largest asteroid sample any spacecraft has ever brought home. Both amounts sound tiny. Both were more than enough to rewrite what scientists thought asteroids were carrying. Number 8. The ALH 84001 meteorite. In August of 1996, NASA held a press conference that made the front page of nearly every newspaper on the planet. Standing next to NASA's Associate Administrator, Wesley Huntress, scientist David McKay unveiled a fist-sized rock and told the room something no space agency had ever said out loud with this much confidence. This rock might contain evidence of past life on Mars. The rock was ALH 84001, picked up off the Antarctic ice by a meteorite hunting expedition back in 1984 and sitting in storage for years before anyone realized what it actually was. In 1993, researchers confirmed it had come from Mars, blasted off that planet by an asteroid impact millions of years ago. It drifted through space and eventually landed on Earth's ice sheets, where the cold, dry conditions preserved it almost perfectly until someone finally picked it up. McKay's team had spent years studying the carbonate globules packed into its fracture zones, tiny orange-brown deposits that form when water moves through rock. Inside those globules, under a scanning electron microscope, they found structures that looked unnervingly like fossilized nanobacteria, hundreds of times smaller than any bacteria known on Earth, but shaped the way biology shapes things. Kathy Thomas Kepperda, a member of McKay's team, went further. She examined magnetite crystals inside the rock under a transmission electron microscope and found them nearly identical, structurally and chemically, to magnetite that certain bacteria manufacture right here on Earth, aligned in chains the way a compass needle lines up bacteria that navigate using Earth's magnetic field. That's not a typo, by the way. A rock from Mars appeared to contain the same kind of magnetic crystal that living organisms build for their own use. McKay's team never leaned on just one piece of evidence either. Alongside the carbonate globules and the magnetite, they pointed to polycyclic aromatic hydrocarbons embedded in the rock, complex organic molecules that can form when organic material breaks down. They treated all of it together as one combined case, rather than any single knockout data point. If you're enjoying this so far, go ahead and subscribe, because this list only gets stranger from here. But the scientific community did not simply accept it. Within a year, a research team led by geologist Bradley published a rebuttal. The fossils, they argued, were nothing more than magnetite crystals that had grown in careful alignment along the mineral itself, a natural crystallization process with no biology required at any step. Thomas Kepperda and McKay's group pushed back through the 2000s, with further electron microscopy defending their original read, and that fight never fully resolved. 3 decades later, planetary scientists still argue about ALH 84001 at conferences, some defending the biological interpretation, others insisting it's crystal geometry doing a convincing impression of life. Nobody has definitively closed the case in either direction, and no Mars sample return mission has yet brought back fresh material specific enough to settle it for good. What's left, after all that argument, is a rock that NASA once stood behind at a nationally televised press conference, containing structures that still, to this day, nobody can fully explain away. Not proven, not disproven either. And ALH 84001 isn't even the strangest thing this list has to offer, because the next entry doesn't just claim a fossil shape. It claims the literal missing ingredient for life itself, confirmed directly, in a place nobody expected to find it. Number 7. Enceladus's phosphorus. NASA's Cassini spacecraft spent 13 years orbiting Saturn, from 2004 until it burned up in Saturn's atmosphere in 2017. During that time, it flew repeatedly through the icy spray coming off Enceladus, one of Saturn's smaller moons, sampling grains of ice flung out into Saturn's E-ring by geysers erupting from cracks near the moon's south pole. Underneath that ice sits a liquid ocean, kept warm and liquid by the tidal squeeze of Saturn's gravity flexing the moon's interior. Every time those geysers fire, they're spraying a piece of that ocean directly into space, where a passing spacecraft can catch it. For years, scientists studying that spray, and the data Cassini had already gathered, found plenty of the ingredients biology needs: carbon, hydrogen, nitrogen, oxygen, sulfur, plus complex organic molecules identified in a 2018 analysis. 4 out of the 6 elements every known living thing on Earth is built from, but one element kept refusing to show up, no matter how closely anyone looked. Phosphorus, the rarest and least abundant of the 6, the one every cell on Earth needs to build its own genetic code and its own cellular energy. Then, in June of 2023, a team led by Frank Postberg at the Free University of Berlin went back through Cassini's old cosmic dust analyzer data and found it. Sodium phosphates, sitting directly inside those ice grains, at concentrations at least 100 times higher, maybe as much as 1,000 times higher, than the phosphate levels in Earth's own oceans, published in the journal Nature, confirmed, not inferred. That makes Enceladus the only place besides Earth itself where every single one of the 6 essential elements for known biology, the ones scientists group together under the acronym CNOPS, has actually been detected, directly, in the same environment. And somehow, it gets even more specific than that. The phosphorus wasn't locked up in some mineral form a cell could never use. It showed up as soluble phosphate, dissolved and chemically ready to react. It's sitting inside an ocean that's been kept liquid for who knows how long, by nothing but the gravitational squeeze of a planet 900 million miles from the sun. Some scientists compare the conditions down there to the hydrothermal vents on Earth's own ocean floor, the same kind of environment where some researchers think life on Earth may have started in the first place. To be clear, none of this means anything is alive down there. It means the chemistry is finally complete. Every ingredient known biology has ever needed, sitting together, in liquid water, on a moon most people couldn't point to on a map before this discovery made headlines. The find is already reshaping how seriously NASA takes the moon as a target. Enceladus now sits high on the short list for a dedicated future orbiter or lander concept, specifically because it's the only ocean world where a spacecraft doesn't need to drill through miles of ice to sample it. The ocean sprays itself into space for free. But finding the full recipe isn't the same as finding a meal. The next planet over from Enceladus already has scientists publicly arguing about whether they found something closer to the meal itself. Number 6. Venus's phosphine. In September of 2020, a team led by Jane Greaves at Cardiff University announced something that made headlines around the world. Using the James Clerk Maxwell Telescope in Hawaii, which had gathered its data back in 2017, and the ALMA array in Chile, which added a second independent set of observations in 2019, they detected phosphine gas in the clouds of Venus, roughly 20 parts per billion of it, floating in a layer of the atmosphere where temperatures and pressures are almost survivable. And here's the detail that made it a story instead of a footnote. On Earth, phosphine at that altitude has no known way of forming without biology behind it, whether that's anaerobic bacteria or industrial manufacturing. Venus is not exactly a candidate for life by any normal definition. Its surface hits nearly 900 degrees Fahrenheit, hot enough to melt lead, under crushing pressure 90 times that of Earth, wrapped in clouds made of concentrated sulfuric acid. But the cloud deck, 30 to 40 miles up, sits at almost survivable temperatures and pressures, somewhere between freezing and a warm day. And that's exactly where the phosphine turned up, right in that one narrow habitable band on an otherwise hostile planet. The reaction from the scientific community was immediate, and it wasn't polite. A team led by Geronimo Villanueva at NASA's Goddard Space Flight Center published a rebuttal within weeks. Greaves's team, they argued, had misread the signal entirely. What looked like phosphine was actually an ordinary Venusian gas, sulfur dioxide, showing up in a similar part of the radio spectrum. Villanueva's paper all but told Greaves to retract the finding outright. This is where most people assume the story ends. Phosphine debunked, case closed. It doesn't end there. Greaves's team went back, reprocessed the same ALMA data using a corrected model of Venus's atmosphere that accounted for contamination from the planet's own thin atmospheric layers, and found phosphine again. Just less of it. The planet-wide average came out closer to 1 to 4 parts per billion, with some localized spots peaking at 5 to 10. Lower than the original number, but not zero, and not fully explained by sulfur dioxide either. A follow-up 2022 paper from part of the same research group went further, reporting a possible detection of ammonia in Venus's clouds as well. Like phosphine, it's a second gas with no easy explanation in an atmosphere that's almost entirely carbon dioxide and sulfuric acid. That finding is even less settled than the phosphine itself. So the gas is there, in some amount. What's making it isn't settled, and neither side of this fight has walked away. It could be some exotic volcanic chemistry nobody has modeled correctly yet. It could be photochemistry in a cloud deck stranger than anyone assumed. Upcoming missions, NASA's Da Vinci probe and ESA's Envision orbiter, are both partly designed with this exact question in mind. Or the phosphine could be exactly what it looked like at first glance, and right now, nobody in planetary science wants to be the one who says that part out loud in public. One planet fighting over an unexplained gas is one kind of mystery. The next star on this list has been fighting over its own mystery for over a century, and the proof sits in a stack of photographic glass plates nobody thought to check until it was almost too late. Number 5. Tabby's Star. In 2015, volunteers on a citizen science project called Planet Hunters were sifting through data from NASA's Kepler telescope, looking for the tiny, regular dips planets cause when they cross in front of their star. What they found around an ordinary F-type star called KIC 8462852 wasn't tiny or regular. It was dimming by up to 22% at a time, in irregular dips that didn't repeat on any clean schedule at all. That's not a pattern any planet, no matter how large, could ever produce by crossing in front of a star. Astronomers nicknamed it Tabby's Star, after Tabitha Boyajian, the researcher who led the paper describing it. And in 2016, Jason Wright, an astronomer at Penn State, did something most astronomers never do in a serious peer-reviewed paper. He formally proposed, alongside more conventional explanations like comet swarms, that the dimming could be caused by an artificial megastructure, something built on purpose, orbiting the star and blocking its light. The SETI Institute pointed its Allen telescope array at the star specifically to search for radio transmissions. It found nothing. Boyajian's own team later ran a public crowdfunding campaign, nicknamed Where's the Flux, to pay for the dedicated telescope time needed to catch the next dip in real time and finally settle what was actually blocking the light. But here's the part almost nobody covers when they tell this story. While everyone was focused on the Kepler dips, astronomer Bradley Schaefer at Louisiana State University went digging somewhere nobody expected: Harvard's archive of old photographic plates, some of them exposed before your great-grandparents were born. He pulled 1,338 plates, spanning 1890 to 1989. Tabby's star, he found, had faded by nearly 0.2 of a magnitude over that entire century, a rate no F-type star has ever shown before or since, in any archive anyone has checked. If that sounds like the smoking gun, wait, because it gets messier. A separate team checked plates from Germany's Sonneberg Observatory covering 1934 to 1995. The star's brightness, they found, had stayed constant, within 0.03 of a magnitude per century. That flatly contradicts Schaefer's result, at a confidence level of 5 standard deviations, a level statisticians don't usually get to argue about at all. So which archive is wrong? Nobody has settled that yet. And in 2018, a fresh multi-wavelength observing campaign led by Boyajian's own team found the dips dim more at blue wavelengths than red, which points toward a cloud of dust rather than a solid structure. Dust explains the Kepler dips reasonably well. Dust does not explain why one archive of century-old glass plates shows dramatic, unprecedented fading, and another archive covering roughly the same century shows none at all. That contradiction is still sitting there, unresolved, in two different vaults of astronomical history, one in Massachusetts and one in Germany, disagreeing with each other about the same star. And while one star's paperwork stays tangled up in an argument over plates, an entire research team just ran that same kind of search on purpose, across 5 million stars at once, and came back with 7 survivors. Number 4. Project Hephaestus. Back in 1960, physicist Freeman Dyson proposed that any civilization advanced enough to outgrow its home planet would eventually build a structure around its entire star to capture every scrap of its energy output, a shell, or a swarm of collectors, now known as a Dyson sphere. For decades, that idea sat mostly in science fiction and the occasional speculative paper. Searching for one meant sifting through millions of stars, looking for one very specific signature, a star radiating far more heat in infrared light than its visible brightness should ever produce, as if it were wrapped in something re-radiating captured energy as waste heat. At Uppsala University in Sweden, a researcher named Matthias Suazo finally built a search rigorous enough to do it properly. His team constructed a purpose-made filtering pipeline, including a neural network trained specifically to catch the false positives that had sunk earlier, cruder searches, like similar work done years before, using data from NASA's WISE mission. Then he pointed it at roughly 5 million stars cataloged across 3 different sky surveys: Gaia, 2MASS, and WISE. Earlier attempts at this same kind of search, including one Jason Wright himself ran out of Penn State using WISE data alone, had turned up candidates too, but nothing that survived this level of scrutiny. Out of 5 million candidates, 7 stars survived every single filter. All 7 were small, cool red dwarfs, the kind of star that burns for tens of billions of years, longer than any other class. That makes them, in theory, some of the best real estate in the galaxy for a civilization patient enough to build around one. All 7 showed a spectral signature matching blackbody temperatures between 100 and 300 Kelvin, precisely the temperature range a partial Dyson swarm would be expected to glow at. And no known natural explanation, no ordinary debris disk, no background contamination anyone could immediately point to accounted for the excess heat. If you're enjoying this list, hit subscribe, because the last 3 signs get harder to explain than anything you've heard so far. By late 2024, follow-up teams had trained bigger, more precise telescopes on all 7 candidates, specifically to check the original work. And the checking paid off, at least partly. High-resolution radio imaging on one of the 7, Candidate G, revealed the actual radio source sitting more than 5 arc-seconds away from the star itself. It traced back instead to a background active galactic nucleus, an entirely different, vastly more distant object that had nothing to do with the star at all. One candidate, eliminated by the same rigor that flagged it in the first place. That leaves 6. 6 red dwarf stars, flagged out of 5 million, that still, as of the most recent published follow-up, have no confirmed natural explanation for the heat they're giving off. Not proof of a Dyson sphere, not ruled out as one either. Just 6 unresolved dots on a very short list that started with 5 million stars and a 60-year-old idea nobody had the tools to properly test until now. A search across 5 million stars finding 6 unexplained survivors is one kind of evidence. The next entry on this list isn't a survey result at all. It's a single, specific, already named star, sitting almost exactly where the most famous unexplained signal in the history of SETI came from. Number 3. The WOW signal. On the night of August 15, 1977, a radio telescope in Ohio called Big Ear recorded a 72-second burst of narrowband radio noise at exactly 1420 MHz. That's the frequency hydrogen naturally emits across the universe, and the exact frequency every SETI search treats as the most likely channel an alien transmission would use on purpose. Astronomers call it the water hole, because it sits between the natural radio emissions of hydrogen and hydroxyl, the 2 pieces that make up water. Astronomer Jerry Eman was reviewing the printout days later when he found it, a string of characters representing signal strength far above anything else on the page, reading 6EUJ5, circled it, and wrote one word in the margin: wow. That signal was never heard again, not that night, not in any search since, across nearly 5 decades of people pointing telescopes at the same patch of sky hoping for a repeat. In 2017, one researcher proposed a hydrogen cloud around a passing comet as the source. But follow-up analysis found comets in that region of sky don't produce anything close to matching the signal's strength, and the explanation didn't hold up. For over 40 years, the one thing everybody actually knew about the WOW signal, which direction it came from, sat there mostly unused. Nobody had the tools to do anything productive with it. That was about to change. In November of 2020, an amateur astronomer named Alberto Caballero did something nobody had done with any real rigor before him. He pulled data from the European Space Agency's Gaia mission and searched specifically for sun-like stars sitting in the exact direction the WOW signal had come from. He found 66 candidates, but one of them stood out from the rest by a wide margin. Catalogued as 2MASS 1928-1982-2640123, sitting in the constellation Sagittarius roughly 1,800 light-years away, this star is close to an exact twin of our own Sun, matching its temperature, its radius, and its brightness almost perfectly. Out of 66 candidates in that same patch of sky, it's the only one that looks like a solar system's front door. That's the strongest candidate host star the WOW signal has ever had, in over 4 decades of searching. Caballero didn't stop at one name either. He kept the other 65 candidates on record too, in case the real source turns out to be a fainter, less obvious star nobody would have picked out first. And here's the part that keeps this from being a clean win. Follow-up radio observations, including further searches by teams connected to the Breakthrough Listen project, pointed directly at that star and found absolutely nothing broadcasting there now. No repeat signal, no ongoing transmission, nothing at all. That rules out one thing and one thing only: that whatever sent that burst in 1977 is still sending it in the present day. It says nothing about what happened on that one August night, from that one direction, at that one frequency, picked up by that one telescope, and never once since. A signal with a candidate address is one kind of mystery solved partway. The next entry on this list didn't wait 43 years for an answer. It got analyzed and very nearly confirmed within the same year astronomers even found it. Number 2. BLC-1. Breakthrough Listen is the largest scientific search for alien signals ever funded, backed by roughly $100 million from investor Yuri Milner starting in 2015. It's built specifically to scan the nearest million stars and beyond for exactly this kind of event. On April 29, 2019, as part of that project, the Parkes radio telescope in Australia, nicknamed Murayang, spent hours pointed directly at Proxima Centauri, the closest star to our own Sun, just over 4 light-years away. Buried in that data was a narrowband signal sitting near 982 MHz, and it did something that made the astronomers running the search sit up. It drifted in frequency, slowly and consistently, exactly the way a signal would drift if it were broadcast from the surface of a rotating planet. That's the same kind of drift a radio wave from Earth would show to an alien listener on the far side of the galaxy. Breakthrough Listen's automated pipeline flags millions of candidate blips on a typical observing run, almost all of them satellites, cell towers, or other Earth-based noise. It throws out all but a handful before a human ever looks at the list. BLC-1 was one of a tiny number that made it all the way through that filter. That drift is one of the specific fingerprints real SETI searches are built to look for. And this signal had a second one. It only appeared when the telescope pointed directly at Proxima Centauri, and it disappeared completely every time the telescope pointed away, over and over, in a pattern that's supposed to rule out ordinary local interference. 2 check marks, both real, both exactly what a genuine technosignature is supposed to look like on paper. The discovery wasn't made public until December of 2020, once the Breakthrough Listen team had spent over a year quietly testing it against every explanation they could think of. By the time it leaked into headlines, it was already being called the most serious SETI candidate since 1977. Then, in October of 2021, 2 papers landed in the journal Nature Astronomy. The first, led by Shane Smith, laid out the full search of the Proxima Centauri system. The second, led by Sophia Sheikh, then working at the Berkeley SETI Research Center, ran the signal through a verification framework built specifically for cases exactly like this one. And no, I'm not making this next part up. The signal traced back to an electronically drifting intermodulation product, a kind of interference generated by ordinary human electronics right here on Earth, likely from equipment near the observatory itself. By pure coincidence, It happened to mimic almost every signature astronomers search the sky for, drift and all. 39 more hours of dedicated follow-up observation turned up no repeat of it, ever. So the closest thing to a confirmed technosignature in nearly half a century turned out to be terrestrial static wearing the right disguise. That's either incredibly reassuring or the single most unsettling part of this entire list. It means the exact behavior scientists rely on to identify a real signal from another civilization can also be produced by accident, by equipment sitting near a telescope, or in someone's garage. BLC-1 looked exactly like contact, right up until it got caught. The final entry on this list isn't a signal at all. It's a physical object that flew directly through our solar system, and nobody has ever managed to fully explain it away as interference, dust, or anything else. Number 1. Oumuamua. On October 19, 2017, astronomer Robert Warwick was reviewing data from the Pan-STARRS telescope on Haleakala, in Hawaii, when he caught something moving too fast, on a path that refused to close into any normal orbit around the Sun. Its trajectory proved it beyond doubt. This object had come from outside our solar system entirely, the first interstellar visitor ever confirmed passing through. By the time anyone noticed it, it had already made its closest pass by the Sun, and was speeding back out toward deep space at roughly 196,000 miles per hour. Scientists named it Oumuamua, Hawaiian for scout, a messenger arriving first from somewhere else, and almost immediately, the observations stopped making sense together. Oumuamua was extraordinarily elongated, roughly 10 times longer than it was wide, possibly stretching several hundred feet end to end, more cigar-shaped than anything ever catalogued in our own solar system. It tumbled irregularly as it moved, rather than spinning cleanly on one axis the way most asteroids do. Its surface was redder than nearly every asteroid or comet on record, consistent with either organic compounds or billions of years of irradiation, and it reflected far more sunlight than a rocky object of its estimated mass should ever produce. Any one of those properties alone would be a curiosity worth a footnote. Together, on the same object, they were unprecedented. Then came the detail that turned a curiosity into a genuine, unresolved problem. As Oumuamua raced away from the Sun, it accelerated, at a rate that solar gravity by itself could not explain. Normally when a comet does that, it's because trapped ice near the surface is heating up and venting gas, pushing the object forward like a tiny natural thruster. Multiple telescopes searched Oumuamua for exactly that kind of outgassing, the coma and dust trail every active comet produces. They found nothing. No coma, no gas trail, no dust, no glow of any kind. Whatever was pushing it had no visible source at all. In 2018, Shmuel Bialy and Avi Loeb, who at the time chaired Harvard's astronomy department, published a paper in the astrophysical journal Letters, laying out the most straightforward explanation that fit every single observed property at once. An object impossibly thin, hundreds of feet across but only a fraction of an inch thick, being pushed outward by sunlight itself the way a sail catches wind. An artificial structure. The mainstream scientific community rejected that read and proposed natural alternatives instead. A hydrogen iceberg, a nitrogen iceberg, a loose fractal cloud of dust held together by nothing but weak internal forces. Every single one of those alternatives has run into its own unresolved physical problems since Loeb's paper was published. In 2019, a second interstellar object, nicknamed Borisov, passed through and behaved exactly like an ordinary comet should, gas trail and all, no unexplained acceleration anywhere in its data. That comparison didn't settle Oumuamua's case. It sharpened it, because now there were two confirmed visitors from beyond our solar system, and only one of them followed the rules physics expects a comet or asteroid to follow. The Vera Rubin Observatory in Chile reaches full operations in 2026 and is expected to start finding objects in Oumuamua's size range on a regular basis, rather than by pure accident. What it finds will either explain what happened in 2017 or make it harder to explain than it already is. The real question was never just what Oumuamua was. It's why an object that broke nearly every rule we understand about comets and asteroids was allowed to leave the solar system before anyone got a closer look at it. So that's 10 signs, from a meteorite that fell on a sheep farm in 1969, to an interstellar object that's already gone, farther from the sun with every passing year. None of them, on their own, proves we've found another species out there. Every single one of them is real, published in a peer-reviewed journal somewhere, and still sitting there, unresolved, waiting for the instrument that finally settles it. Let me know in the comments where in the world you're watching this from, and subscribe if you want to see what else is still sitting out there unexplained.